America was sick long before COVID. We typically wait until people are sick before we try to do anything. This is really what our healthcare system is built around. This is just an ass-backwards way of thinking about human health. Pay attention to this, and we should spend some time thinking about what this means and maybe how to avoid a sort of catastrophic collapse of our healthcare system because of the fact that chronic disease has and continues to increase. 21st century medicine really should be about keeping people healthy, preventing them from getting these diseases in the first place. There's a lot that we can do, even with our understanding of biological aging as it is today. My name is Matt Caberline, and welcome to the Optispan YouTube channel. Hey everyone, welcome to the Optispan podcast. So a couple of weeks ago, I had the opportunity to participate in the Alliance for Longevity Initiatives science briefing. This was a briefing for the Longevity Caucus in the United States House of Representatives, and we were fortunate to be joined by Representatives Bilirakis and Tonko, the co-chairs of the caucus. And at that briefing, I gave a presentation on longevity science that I thought might be interesting to include in the podcast. So I'm going to go through that presentation now. And then at the end, I'll give you a little bit more information on the Alliance for Longevity Initiatives. I also, while I was in Washington, D.C., interviewed Dylan Livingston, who is the director of A4LI, and that interview will also be included on the channel, so I'd encourage you to check that out. So I want to start by kind of setting the stage for, one of the reasons why I think that the science of longevity is so critically important to support. And I really think it's useful to appreciate, kind of how we got where we're at in terms of healthcare in the United States. This statement from Lee Hood, I absolutely love. It was in an article that he wrote for, I think, the Los Angeles Times that started, "America was sick long before COVID." And I think in some ways this encapsulates our healthcare system. So, I've talked about before on the podcast, if you look at life expectancy in the United States and other developed countries, it has been increasing pretty consistently over the last several decades until recently. So we actually had a slight downtick from COVID-19, but even since then, it really seems like life expectancy in the United States has plateaued, and it's unclear whether going forward that's going to decline, it's going to sort of flatten out, or it's going to increase. And we've talked about this before on other episodes of the podcast and some of the factors that might influence that. But I think when you look historically at the increases in life expectancy, you can ask the question, has Healthspan really tracked with those increases in life expectancy? And I think the answer is pretty clearly no. I think we can certainly look at some individuals. There are lots and lots of individuals today in their 60s, 70s, and 80s that are healthier than typical people in their 60s, 70s, and 80s were, 30, 40 years ago. But at the population level, if anything, it's gone the other direction. So, I would say health span is probably decreasing. I would say without a doubt, sick span has and continues to increase in the United States. And again, we can define sick span different ways, but I think a reasonable place to start is the presence of one or more chronic diseases or disabilities. And again, I've talked about this before, the Center for Disease Control says that 60% of Americans today have a chronic disease. The average age in the United States is 38.1, roughly. So if you just do the math, that will tell you that on average, the period of sick span is probably about 4 decades in this country right now. And when you combine that with the fact that up to 90% of healthcare expenditures go towards treating chronic disease and disability, you can start to get a feel for really where we're at in terms of the overall health of the country. One of the points I made at the briefing is that both of those numbers are increasing. The percentage of Americans with chronic disease and the percentage of healthcare expenditures that go towards treating chronic disease. And I don't know where the system breaks, but I'm pretty sure that those numbers can't get to 100%. And so I think particularly for the younger people in the audience, you should pay attention to this, and we should spend some time thinking about what this means and maybe how to avoid a sort of catastrophic collapse of our healthcare system because of the fact that chronic disease has and continues to increase. And so I think, as part of that discussion, it's useful to consider, why is it that chronic disease has become so prevalent in the United States and other developed countries? I think there are multiple reasons for that, but one of the big reasons really stems from the way that we have culturally approached health. And I think this is true in pretty much at least every Western society in the world, that, for decades, probably more than even a century, we really have thought about health through the lens of individual diseases in isolation, right? And this is true all the way from the level of basic biomedical research to pharmaceutical drug development to healthcare practice in the clinic. We really think about individual diseases, and we typically wait until people are sick before we try to do anything about their condition, right? This is the idea of reactive disease care. This is really what our healthcare system is built around, waiting until people are sick before we try to do anything about their health. So one of the consequences about this individual disease focus is that we often lose track of the fact that most of the major causes of death and disability share a single greatest risk factor. In fact, if you look at the top 10 causes of death in the United States, 9 of them share the same greatest risk factor. And that greatest risk factor is how old you are. So this gets back to the idea that aging really is the factor that drives the increased risk of developing many, many different functional declines and diseases as we get older. And if we can understand aging at a biological level, molecular, genetic, biochemical perspective, if we can understand aging that way, it gives us the opportunity to actually target those mechanisms in order to delay the onset and progression of many, maybe all of these major causes of death and disability simultaneously. And again, this is really what I hope and believe will become 21st century medicine. So again, 20th century medicine, 19th century medicine has really been about targeting individual diseases in isolation. And a consequence of that is that we have done a good job of keeping sick people alive. 21st century medicine really should be about keeping people healthy, preventing them from getting these diseases in the first place. And again, I believe that targeting the biology of aging has to be a big part of that equation. It's not the only thing, but it needs to be a big part of that. And so I think it's useful to appreciate that this is doable, right? That we are starting to understand biological aging at a molecular, genetic, biochemical level. And so it's useful to appreciate, a couple of different concepts. Again, I know we've gone into great detail on biological age and chronological age in other episodes of the podcast. But again, chronological age is really just the length of time that you're alive, and we differentiate that from biological age, which is really what's driving the increased risk of developing these functional declines and diseases. Biological age has to do with how old your cells are in terms of tissues and organs and physiological function, right? And I think dogs are a really easy example for people to appreciate the difference between biological age and chronological age. Everybody is familiar with the idea that 1 human year is about 7 dog years. All that means is that dogs age biologically about 7 times faster than people do, right? And so we can appreciate that looking across species, comparing dogs to humans. What's important to appreciate is there's also differences in the rate of biological aging within individuals, right? We all know people in our own lives who seem to be aging biologically either more slowly or more quickly than everybody else, right? And so individual variation in the rate of biological aging reflects itself as individual variation in overall health status and likelihood of going on to develop or having previously developed one or more of the variety of different age-related functional declines and diseases. So The thing to appreciate, though, is that biological age, not only is it a real thing, but we're starting to understand it. We're starting to gain insights into these mechanisms that control the rate of biological aging at both the species level and the individual level. And one of the ways to appreciate this is through the lens of the hallmarks of aging, of which we actually have an entire episode focused on the hallmarks of aging. So I'll refer you to that. But the hallmarks of aging really represent a sort of more or less consensus right now on what we understand about the mechanisms that drive biological aging. And it's useful to appreciate that these hallmarks are connected. There's a network that underlies the hallmarks that we can target specific proteins or genes or other factors to modulate the rate of aging, at least in laboratory animals. It's also useful to appreciate, though, that there's a lot of work that needs to be done. So I've shown this graphic before. I know it frustrates some people, but this is a graphic of the known Earth in 500 BC, right? And this clearly reflects a somewhat inaccurate assessment of the surface of the Earth, right, compared to what we know now. There's a sort of oversized Libya, a vaguely Europe-shaped Europe, something that looks nothing like what Asia actually looks like. And then my favorite part is that it's surrounded by ocean, and if you sail too far, you kind of fall off the edge of the planet, right? So maybe this sort of reflects our current understanding of biological aging. Maybe we understand biological aging a little bit better than this, but there's a lot we don't understand, and I think there's no question there's far more that we don't understand than we do understand about the biological aging process. I do want to make a couple of points, though. So one point is it's exactly this knowledge that still remains to be understood that I think makes the case for why it's so important to support fundamental basic research into the biology of aging, which, as I'll get to in a minute, has been dramatically underfunded over the last decades. The other thing that's important to appreciate, though, is that even if our understanding of biological aging is fairly rudimentary right now, maybe it's equivalent to what our understanding of the surface of the Earth was in 500 BC, this map in 500 BC was pretty darn useful, right? People could use this map to explore, to trade, to make political agreements, alliances, right? So there's a lot that we can do even with our understanding of biological aging as it is today. And many of the companies that have sprung up in the longevity biotech sector are aimed at directly targeting these hallmarks of aging, right? These mechanisms that we do understand. And again, at least in laboratory animals, doing that has pretty profound effects on both longevity and health span. So I think there's real opportunities, even given our fairly rudimentary understanding of biological aging today, to have very large impacts on health span and potentially lifespan in people. And I would say, without a doubt, the opportunities are there to have a much larger impact on health span than what we can accomplish through individual disease-focused approaches, which is what we've taken up till this point largely. Okay, so here's the idea, right? So if we look at health across the population, what we see is that on average, health declines with age. Obviously, different people are different and health can go up and down over time in individuals, but across the population, in general, health is declining as a function of age. We all get this, right? A typical 70-year-old is not as healthy as a typical 50-year-old, is not as healthy as a typical 30-year-old. And I think what's important to appreciate that I alluded to earlier is many people, maybe a majority of the population, are spending 30, 40% of their life with significant declines in health, significant chronic disease. And so the opportunity, as I see it today, is really to move that health span curve out so that more people are living a greater proportion of their life in relatively good health. Now, the graphic here is an idealized case, right? Nobody is actually suggesting that we're going to make everybody live till 90 years old and then they're going to fall asleep one day and not wake up the next day in perfect health, right? But I think we can get a lot closer to that idealized case. And, we really believe at Optispan that there are opportunities to get 20 years of added good quality health for the typical American. This is the concept we refer to as the lost decades, right? That many people have the opportunity to gain 10 to 20 years of added health span. And, honestly, most of that doesn't necessarily come from the sort of cutting edge geroscience approaches of targeting the biology of aging. It comes through things like optimizing lifestyle and catching pathology, disease, before it actually becomes overt disease. So preventative diagnostics, preventative approaches. I think those two buckets can get you most of the way there. I do want to make the point, though, that the reason why optimizing lifestyle has this effect of reducing your risk for multiple age-related functional declines and diseases is precisely because optimizing lifestyle slows biological aging. And we actually understand some of the mechanisms there. So this is a geroscience approach, even though it's also something that we all sort of already know about, right? Diet, so optimizing nutrition, regular exercise, getting good quality sleep, even the human connection mindfulness piece, reducing stress, those things impinge on the biology of aging, and that's why they have such a profound impact on health. I do also think that there is a place for what I refer to as Generation 1 geroscience biomarkers and interventions. These things may not be quite ready for prime time, but the tools that are coming online to monitor biomarkers of biological aging and some of the interventions that we're interested in, things like rapamycin potentially, I think may play a role here in terms of helping people achieve this sort of health span trajectory that is getting closer to the idealized case. So I actually think these are things we can do today and we should do today. And that's really what Optispan is all about. So then the question becomes, what can we do tomorrow? And this, I think, is the sort of optimistic, forward-looking view of geroscience and why it's so important that we support geroscience research more than we have, incentivize geroscience approaches in biotech and drug development, and accelerate this transition to 21st century medicine. So can we do better than just helping people recapture the lost decades and actually push the population life expectancy and health span expectancy out, maybe closer to what we currently think of as the species maximum? I don't think this is possible given what we know today. I don't think we have anything that will get us close to accomplishing this today. I don't know, maybe rapamycin, maybe some of the things that are currently being studied in the laboratory can do that, but I haven't seen any data yet in people that makes me think that's the case. But I absolutely believe it's possible. In fact, I believe it's possible to do better than this. But I don't think it's going to happen unless there is a concerted effort to start thinking outside of the box, or as I say, looking outside of the longevity lamppost. I think we need new innovative strategies to really understand the biology of aging at a deeper level and explore that biology in ways that may not be happening right now. And Aura Biomedical, I think, is one example of a company that's doing this. Aura Biomedical is a company that has developed very high throughput longevity drug discovery technology, the Million Molecule Challenge. Aura is a company that we spun out of my laboratory at the University of Washington, so I know Aura Biomedical very well. I am a co-founder of Aura Biomedical, and I'm very excited about what's happening there. That's not the only company that is sort of exploring around the edges, but it's one that I'm particularly excited about. And I think we need more of these innovative approaches to get outside of the hallmarks of aging paradigm. So where do I think that there are really some real opportunities from a policy perspective where I would like to see the Longevity Caucus and some of our political leaders who are interested in this space think about how can we maybe make some changes at the policy level? So I think one obvious place is federal funding for research. And I, for many years, have been an advocate for more funding for NIH. I have gone to Capitol Hill as part of the FASEB Capitol Hill Days, talked to congresspeople about the need, the importance of federal funding for basic biomedical research. Having said that, I'm quite frustrated with the way that NIH is functioning. And I very much believe that there is a need for pretty significant reform at NIH. That this is probably a longer conversation, but I think there is an important need for reform at NIH. It is highly inefficient, both in the way that the resources are distributed and where they're distributed. And so as part of that, I very much believe that there should be a reallocation of funding within NIH away from reactive disease model, more towards a proactive health model. And just to illustrate that, if you even just look at the structure of NIH, NIH is structured around reactive disease care. There's a cancer institute, there's an infectious disease institute, there's a heart, lung, blood institute, there's a neurological disease institute, there's a diabetes and kidney disease institute. So this is the whole lens of federal research is through studying individual diseases in isolation, which in my view completely misses the important point that all of these diseases generally, not all of them, most of these diseases are tied together through the lens of the biology of aging. So if you look at the funding levels for the different institutes, National Cancer Institute, fiscal year 2023, got about $7.3 billion. Allergy and infectious disease got about $6.6 billion. National Institute on Aging is the third best funded institute at $4.4 billion. So you might look at that and say, well, aging, sure, maybe it should get as much as cancer, but it's not that underfunded. The problem is that even within the National Institute on Aging, the fraction of that $4.4 billion that actually goes to biology of aging is tiny. The majority of research spending within National Institute on Aging goes to Alzheimer's disease. Again, reactive disease approach to research and healthcare. So when we look at the pie from the perspective of, how much of the federal funding goes to biology of aging, it's about 0.5% of the total NIH budget. So I'm going to say that again, because I think this is a really important statistic to appreciate. 0.5% of federal funding through NIH for biomedical research goes to study the single greatest risk factor for nearly every major cause of death and disability in the United States. That to me is insane. It makes absolutely no sense at all. And many of us have been pointing this out for a while now, and it hasn't changed. And that's quite frustrating, as you can imagine. There are good reasons for it. Well, I don't know if there are good reasons for it. There are reasons for it. But this is just an ass backwards way of thinking about human health. And it's starting from the level of very basic biomedical research. And it really needs to change. So I would like to see policymakers step in and help reallocate these resources in a way that is going to have a much larger impact on overall health for people in the United States and the rest of the world. And I hope that happens. So appreciate, though, how tiny the fraction of the resources are that have gone to the biology of aging, and really how much progress has been made in the field given the dramatic under-allocation of resources that, at least to date, have gone towards this problem. So I actually think it's pretty impressive. So the other places where I think that there are real opportunities from a policy perspective for the Longevity Caucus to have an impact are at regulation, and in particular, FDA. I think that, again, there are lots of things at FDA that aren't working. I think we all recognize this, or they aren't working as well as they could. In particular, I think a couple of opportunities are around the realm of potentially prioritizing development of geroscience interventions, right? So creating incentives for either faster review potentially or fast track approval processes for interventions that target the biology of aging. So that's been done for, rare diseases previously. There's the mechanism is there, and potentially that mechanism could be used, or a similar mechanism could be used to incentivize companies to develop therapeutics that target the biology of aging. Now, I'm not suggesting that aging should be the endpoint or lifespan should be the endpoint. In fact, it shouldn't be. But I think that there are plenty of endpoints that if you successfully target the biology of aging, where you can show an improvement in quality or quantity of life for people. And that's the goal in order to get a drug approved at FDA. So I'd like to see some thought put into how we might prioritize geroscience drug development from a regulatory perspective. I also think it might be worth reconsidering the way that FDA regulates supplements versus medications. And in my personal view, I think that the supplements are pretty dramatically underregulated, and we end up actually learning very little from the way that supplements are used in this country because of the lack of regulation. And I think that in some ways, prescription medications are over-regulated by FDA. And I think rapamycin is a good example of this, at least in my view. So I would like to see at least some thought put into kind of rebalancing the way that FDA thinks about regulation of these different modalities of intervention, and a little bit more thought put into a balanced risk-reward analysis for the way that we regulate these things. And then finally, in healthcare, I think there are really lots of opportunities here where policymakers could incentivize this shift from 20th century medicine to 21st century medicine. So incentivize prevention over reactive disease care. And I think, conversations with payers and the way that insurance reimbursement works, incentivizing hospital systems to focus more on keeping people healthy rather than keeping people sick, and encouraging providers to practice this kind of medicine. And again, I think that there are obviously complications with all of these things, but like I said, I believe there are real opportunities, and I'm hopeful now that we're starting to get this beginning of a conversation happening on Capitol Hill, that there will be opportunities at the federal level and also at the state level for maybe actually making some inroads here to have an impact. In any case, I really found the whole experience of participating in the A4LI event in Washington, D.C. to be quite inspiring. Like I said, I think it's the beginning of a conversation, but it's a very positive conversation. And I'm encouraged that, some of our political leaders, at least now, are starting to pay attention, starting to dig in, lean in, understand the concepts here, and hopefully we'll be able to continue this conversation and have an impact. So I just want to finish up by recommending that any of you listening, if you support the longevity cause and you agree with what I've been talking about here, please consider checking out the Alliance for Longevity Initiatives, a4li.org, and consider becoming a member. So the membership is really cheap. I think it's $50 a year. As part of your membership, you get discounts on a variety of different products and services in the space, and that will be expanding. A4LI is a 501c4, so it is a nonprofit organization. I have been super impressed with how much A4LI has accomplished with the shoestring budget that they've had. And everything I saw in DC makes me believe that they're going to go forward and do important things in terms of shifting this policy discussion in the direction that we want to see it go. So please consider going to A4LI and becoming a member of A4LI. So I hope you found this presentation interesting and informative. As always, please feel free to leave any comments or questions below, and I'll see you next time on the Optispan podcast.